Okay. Now, when we do some chemical reaction in the laboratory, no, in that process also the KMnO4 is being prepared. Okay. In laboratory, KMnO4 can be prepared by oxidation of manganese. This is called manganese. Manganese salt by peroxy disulfate. Don't get scared. Peroxy disulfate. I told you in sulfuric acid. 2 Mn2 plus. See, peroxy disulfuric acid, you know it very well. This is peroxide disulfide. This is the peroxide which oxidizes. So if you have any problem within bracket, you can write here. So I write now here. S2OA2 minus plus 8H2O. This one you thought. So it will give you 2 MnO4 minus plus 10 sulfate. Okay. Plus 16H plus. So this way, this also going to oxidize by red lead also. Or sodium bismuthate. Okay, now properties. It is a crystalline solid having melting point of 523 Kelvin. It forms needle shape crystals having dark violet color with a greenish luster. It is moderately soluble in water. Okay, now I'll write down separately for your entrance. It exhibits weak temperature dependent paramagnetism. See, actually in we know any ion which is or oxidation state having unpaired electron shows paramagnetism, but in case of manganese here is +7, so it does not have any single unpaired electron, so it should be diamagnetic. But whenever you heat it, in that case you find the paramagnetism occurs. So it is a very unique thing. I'll tell you just now. Okay, finish this and after that I'll tell you. মাথা সাবান দিলে দেরি যায় না। Don't talk to it. I don't know whether it will ever be asked in any entrance exam or anything like that. See, first of all, in manganese +7, manganese is in +7 oxidation state. It is only air. Okay, it is 3D04S0. As per theory, it should be colorless because no unpaired electron. No unpaired electron, and it should not show any type of paramagnetism. So, in such case, manganese should be colorless and diamagnetic. Why? Due to the absence of any unpaired electron. But we find that it has an intense color. It is an intense color. And at higher temperature, it shows paramagnetism. It's very straight. See why it is like. See, this is the structure of permanganate. And if it is manganate here, then it will be this. This is manganate and this is permanganate. See, if this ion is highly stable, you know why? Because of resonance.
Sir, what is that after colorless
and diamagnetic due to absence of any unpaired electron. Okay? See now, It undergoes resonance. What you will have now here? This. This. It goes to extensive resonance. See here. So it will be like this. So now what happens? Every time when electron from one oxygen travels to another oxygen, it goes through the d orbital of manganese. And it goes as a single electron. And that is the one which makes it colored and it shows paramagnetism. This is a very interesting thing. Okay, so please remember. So I need not draw the structure of MnO4. This is the structure. Your own language, you will write while carrying out resonance, the electron passes through the d orbitals of manganese. Hence, it acquires color and show paramagnetism. Okay. So, properties, I'm going to write some of the properties which is not being given in your book. So, I have taken little liberty, and it's only because of your entrance exam. Okay. So, chemical properties. Yeah. না ওইটাতে ভালো তো আচ্ছা ঠিক আছে তুমি ওর কথাটা বুঝে না না তখন আমার দেখো হবেটা কি রেখে কোন লাভ আছে এটা তো দুই দিনে সিরিজ হবো chemical properties. First is action of heat. This is there in your book. Action of heat. It is stable at room temperature, but decomposes on heating. Sometimes this question comes, what is the action of heat? So it will give you K2 MnO4 plus manganese dioxide plus O2.
কালকের আওয়াজটাতে কোন দিকে আমি বুঝি
When heated with alkali, it also decomposes to liberate oxygen. This is not there. Okay. So it is 4 KMnO4 plus 4 KOH. It will give you 4 K2MnO4 plus 2H2O plus O2. See here, you don't get manganese dioxide. H2SO4. That is not there in the book. Cold and concentrated H2. This is not there in the book. 2 KMnO4 plus H2SO4. It gives you, please see here. This one is study you have read, manganese heptoxide, but it is highly unstable. Okay. Potassium sulfate and H2O. Mn2O7 is highly unstable and decomposes to Mn2O7, gives you 4 MnO2 plus 3O2. Okay. Now B. When warm, gently with concentrated H2SO4, it produces oxygen. So it is KMnO4 plus H2SO4. It is 4, it is 6. It will give you 2 potassium sulfate, 4 manganese sulfate. On mona aise bolo. Bolo. Ice. 6 H2O and 5 water. This is there in our book. But I don't know this there or not. Oxidation reaction. Oxidation reaction. Okay. Oxidation reaction. Dear, please give me 2-3 minutes. I'm coming. Water has come. Camenophore is a strong oxidizing agent and it oxidizes in acidic, alkaline as well as
তুমি আজকে এমনিতে
in
দুটো ওর করে না গাজর না তো
neutral
খেতে রেখে দিও ওই সুজি বানিয়ে দিব না
media.
কুচি কুচি করে কেটে রেখে দিও তারপরে
Okay, right? Then I'll wrap the whole boot. I'll do it again.
ডিম আছে হ্যাঁ দিয়ে দাও দিয়ে দাও তাতে দিয়ে দাও
আমি বলে মন করলাম অন্যটা ফুল see here now acidic media
আর কালকে যে বিলস করেছো বিলস কিন্তু সিদ্ধ হয়নি পরশুদিন যে বিলস করেছিলে বিলস সিদ্ধ হয়নি বিলস হ্যাঁ
camenophore
সিদ্ধ হয় নাই
H2SO4. Okay, so it is K2. Sorry, dear. This is the conventional equation writing. But I'll always tell you, don't go for it. It is very tedious. See here, 2 separate here 2. So potassium value, manganese here it is. I could write here. Okay. Then how many sulfate? 1. plus 2, 3. All right. Then I write here sulfate is also balanced. The 6 hydrogen. 3 H2O. Total oxygen is, you don't count this oxygen because we have already taken into account. Okay. So how many oxygens are there? Sorry, don't take this one. This we have already taken. Now we have how many oxygen? 2 into 4, 8. 8 minus 3. So it is
এটা করতে পারলে তো ব্যাপারটা একটু
5 oxygen. This is the oxygen which oxidizes.
ওটা দিয়ে রাখে
We didn't report this. Dabur or Patanjali had in with the 80% sugar solution.
এটা তো
So this is a bit tedious. Now, if you go for unreacted method, the life is very simple. See here. MnO4 minus. It is plus 7. What does it give? See, manganese. So iron is what? Mn2 plus. The oxidation state is plus 2. So plus 7 is becoming plus 2. So it has to take 5 electron. And in acidic medium, oxygen is being always converted into water. And in that case, it will take hydrogen from water. So I write now here 8H plus. So it will give you OH2. See, camenophore is being used in redox titration. So in that case, you have to make normal solution. Normal solution. Incidentally, now you are having, you do not have practical. Otherwise, in class 12, these practicals are there. So whenever you carry out any redox titration by permanganate, we call them as permanganometry. So you have to make a normal solution. How do you make a normal solution? In that case, we dissolve in equivalent mass. In molar solution, you dissolve molecular mass. But in normal solution, we dissolve in equivalent mass. So equivalent mass of an oxidizing agent is nothing but the molecular mass divided by the number of electrons involved in the reaction. So this is entrance exam. Equivalent mass of camenophore in acidic medium. It's very strange. This only happens in case of the camenophore. So what should I write now here? Equivalent mass is equal to molecular mass of camenophore divided by number of electrons involved in the process. So how many electrons are involved? 5 electrons. Okay. So molecular mass of camenophore is 158. And how many electrons involved? 5. So the equivalent mass is 31.6 gram. Now in second, in neutral or mild alkaline medium, see, what is the equation here? Equation is 2 camenophore plus H2O. So it will give you 2 manganese dioxide plus 2 KOH plus 3 O2. See, it gives you 5 oxygen, but 3 oxygen. So I'll write down this ion electron method. So it is manganate minus plus 7. What does it give? Manganese dioxide is a covalent molecule, so it is a neutral molecule. Here it is plus 4. So plus 7 has come down to plus 4. How many electron I have to add? 3 electron. Now, in this case, I have to remove oxygen. I cannot add H plus. So in that case, what is going to happen? You will find, remember in long time back, we have studied all these things. Huh? So it will give you what? 2OH minus. So I have to remove 2 oxygen. So 2H2O will give you 4OH minus. So what will the equivalent mass here? Equivalent mass of MnO4 is 158 divided by 3. So it comes to 52.67. 52.67 gram. Then third, in strong alkaline medium that we have done also. What happens? See here, KMnO4 in strong alkaline medium, it gives us K2MnO4 plus manganese dioxide plus O. So it is only one oxygen oxidation. So here I'll write now ion electron method. MnO4 2 minus. This is plus 6. And here, sorry dear, plus 7. And it gives you what? MnO4 2 minus. This is plus 6. So it is single electron oxidation. Okay. So what is the equivalent mass? So equivalent mass of MnO4 is what? 158 divided by 1 is 158 only. So is it not equal to molecular mass? So they may ask you, under which condition one normal solution of KMnO4 is 1 molar solution? So you have to write in strong alkaline medium. Okay. Questions are never set in moon. And they will not set your entrance exam question from MSc level. Simple thing which either is not given in a book, or even if you read, that portion you don't read. Only you think, last year what question come? This year this is not going to come. Lab.
Right, sir.
Okay. Okay. Now we'll do oxidation of camphor in acidic medium. Oxidation by camphor in acidic media. Very simple. Only this equation to remember. MnO4 minus. Okay? And this is Mn2 plus. I'm not going to do it the conventional method. This because this equation I know you cannot remember it. So here you will write +7. Here you will write +2. Okay, see. Oh, this number is always written +2. Exactly on the top of the element, and this is called stock sign, STO. STO is stock. Now see here. It is acidic medium. We'll write here 8 plus. +7 has come down to +2. So in that case, it has to take electron. For all the oxygen come into water, so there are 4 oxygen. Each molecule of water contains 2 hydrogen. So I have to write now here 8. And here I'm going to write this. Only this is the one that you have to remember. All other thing will automatically get balanced. Okay. So let us start writing. See some of the reactions we have done yesterday. So what is that? Ferrous to ferric. No? Ferrous. I'll write here. Ferrous sulfate. And here we are going to write ferric sulfate. So let us make it a very simple one. It will be any salt of iron, ferrous salt of iron, ferrous chloride, ferrous sulfate, ferrous nitrate, no problem. It will be converted into corresponding ferric salt. So what should I write now here? I'll write here Fe2 plus. So this is my basic. It is ferric. So I will not do, you will do it by yourself. I'll go very slow. If you say I'll do 2 reactions, but thing is that once you do, you should not forget your whole life. Let us not be in a hurry. See this and this. You know, whenever electron is lost, positive oxidation number increases and negative oxidation number decreases. Then when the electron is gained, positive oxidation number will decrease and negative will increase. So now it has from 2 plus, it has gone to 3 plus. So obviously there should be loss of electron. So I'm supposed to write here -C. Yeah, perfectly correct. If I write -C, you will get this one. But we have to follow the convention. What is the convention? In a chemical equation, we never write anything with negative. So I'll transfer it to the other side. So convention is also followed and our equation is also correct. Now rest you do. Do it. Inorganic equations are not at all difficult. In most of the schools, see, I'm not criticizing your teachers. I do not know why. Either things are not being taught properly, or you are being told right from your school days, by heart chemical equation. No. Science is a question of concept. It is not a question of by hearting. Because the moment you start by hearting, then your logic will finish. I don't know what you are writing. You are
Yes, sir.
so far from me. And somehow, till now, I'm not able to trust you also. You are so dangerous people now. Sufficient to kill many people by your activity. See, 5 electron, I shall multiply it by 5. Then this and this I'll cancel and add. Now, second one, you please do. Iodide, any iodide, sodium iodide, potassium iodide, hydrogen iodide, anything. Iodide to iodine means I minus to I. So you know very well, to get I to I require 2I. So to do what? 2I minus giving me I2. Each iodide will lose 1 electron. This bar indicates 2 electrons. So I have to write here now 2. Then do it again. In ion electron method, first you are supposed to write oxidation followed by reduction.
Done, sir.
Okay. Then next you do third. Hydrogen sulfide to sulfur. Okay. So what should you write now here? It is sulfide S2 minus to sulfur. So you know how to do. S2 minus will give you S plus 2 electron. Do. Then do this 4. Sulfide SO3 2 minus 2 sulfate SO4 2 minus. See here it is SO3 2 minus is plus 4 and SO4 2 minus is plus 6. Okay, so it is going to lose 2 electron, but here you have 3 oxygen, here you have 4. So extra oxygen we can get from water, and here will be 2H plus. So do next. Write this equation. This equation you write of manganese, then balance it. Same thing. What will write now here? Sulfur dioxide. sulfur dioxide to sulfate. See here, everything is same, but only thing is that it is a neutral molecule. So +4 to +6. So you here 2 oxygen, here you have 4 oxygen. So you have to write here now this, and this will be 4H plus. Do it same.
That's it.
Okay. Then some other reactions are there. We'll do next because it's time for others class. Okay. Then bye. Wish you happy weekend.
Bye, sir.